So we defined z-scores here to be x minus mean over standard deviation. That was our formula. And that gives the relative position of a single x value. That's what z-score does. And specifically, it's the number of standard deviations that a value is from the mean. Our mu here again, population mean, sigma, population standard deviation. So positive z-scores above the mean, negative z-scores below the mean. And the importance here is that they let us compare different data sets or different distributions. So let's look at an example here. So Karen and Mia each have a bone density test. Karen's total hip density was 0.742, and then Mia's was 0.684. And then they're in different age categories here, notice. So what we want to do is compare and see how do they compare relative to their age category. So we can't just straight compare the numbers. We want to ask, is 0.742, is that better bone density for the age 60 to 70 category, or is Mia's bone density of 0.684, is that better relative to the age 70 to 80 category? So who had higher bone density relative to their age group? That's what we want to compare. So here we have our means and standard deviations for each distribution. And what we want to do is compute z-scores for each person here. So first up, we got Karen here, and her z-score for her bone density is going to be, well, the x value is 0.742. So that's an x, it's an individual data value. And then the means here, those are mu, and standard deviation, that's our sigma. So 0.742 is our x, minus our mean for the 60 to 70 age group is 784, and then divide by the standard deviation of that age group, 0.461. So let's go ahead and compute there. So 0.742 minus 0.784, and we divide by 0.461. So to two decimal places, negative 0.09. So this is approximately negative 0.09. So that's almost 1/10 of a standard deviation below the mean. Let's go ahead and do the same thing for Mia. So her z-score is going to be, well, her x value here was 0.684. And then the mean for her category is 708. And then divide by the standard deviation for her age category, 375. So 0.684 minus 0.708 is negative 0.024, and we are dividing by 0.375. So negative 0.064 to two decimal places, negative 0.06. So negative 0.06, that's 600ths below. This is 900ths below. So Mia here had higher bone density relative to her age group. So this is greater than negative 0.09. See, what's going on there is you have your bell-shaped curve here. And z equals 0 is in the middle, and then it goes plus 1, 2, 3. 1, 2, 3 to the left, and 1, 2, 3 to the right. So you've got the negative 0.06 would be right here. That's Mia. And then negative 0.09, that's more negative. That's going to be to the left a little bit. So that would be, maybe right here, and that's Karen. So you can see Mia's is higher relative to her age group. It's to the right on our bell-shaped curve. So that's how you compare different distributions. You just compute z-scores for each distribution.